Hello, ladies and gentlemen, and welcome back. We're looking at question 2 on our grade 7 Gauss contest. So what have we got for question 22? An arithmetic sequence is a sequence in which each term after the first is obtained by adding a constant to the previous term. For example, 2, 4, 6, 8. Well, you start with 2, then you add another 2 to get to 4, add another 2 to get to 6, add another 2 to get to 8, then you'd go 10, then 12, and so on. And we've also got another example of an arithmetic sequence, 1, 4, 7, 10. You start with 1, add 3 to get 4, add 3 to get 7, 3, 3, we go 13, then it would go 16, and so on. So these are arithmetic sequences. You just start with some number, you pick another number, you just keep adding that second number on, and you just keep going. Now, in the grid shown, the numbers in each row must form an arithmetic sequence, and the numbers in each column must form an arithmetic sequence. The value of x is. So I got x over here. Now you might not need to fill out the whole grid. If I've got time at the end of the video, and it's my video, so of course I will, I'll fill in the whole grid, but we're just going to focus on getting this x right here. X is over here. And I notice I've got one column that's filled in already. 1, 4, 7, 10. And I already know these go up by 3s each time. Okay. So what can we do from there? Well, let's make a copy of this little grid here. One, 4, 7, 10. There's a 36 down here, a 25 up here, and then the x that we want over here. Okay. So what can we do? How can we get this x? We've only got one complete column, and then we have a couple other numbers, this 25 and this 36, that are just sitting out here, I guess. Okay. Well, what can we do with them? Well, I'm drawn to this 36 because there's a 10 and then something, and then a 36. We might call this something y. I don't know. 10, then y, then 36. We know this needs to form an arithmetic sequence, so you have to go up by the same number each time. And I might call that number n for a number. Just like we go up from 1 to 4 by 3, and then 3 again, and then 3 again. So this allows me to say, all right, to get from 10 to 36, I have to add on some number n twice. Well, I can work out what n is, right? 10 plus 2 n's must be 36. So 2 n's must be 26. So n must be 13. We must be going up by 13 each time in this last row. Okay. So now I don't even need that stepping stone anymore. We're going up by 13s now. 10 plus 13 is 23, plus another 13 is 36. So great, that worked. Plus another 13 is going to be 49. And now look at this. I got 25, I got 49, and I've got x, and they're all in the last column. So this is why I chose 36, was to move along this row to fill in the part of this column. Okay? Now I know it's an arithmetic sequence in this last column, so we're going up by the same number each time. Maybe call it m. And so I know, by the same reason, 25, you add m not once, that gets you to x, but you add it twice, so 2 m's, and you'll get 49. And now if I subtract 25 from both sides, I'll see 2m must be 24, so m must be 12. So we're not going up by m anymore, we're going up by 12. So 25 plus 12 and then plus another 12 should get me 49. Now, at long last, I can work out what x is. It's 25 plus 12, 37. And that's the value of x we're looking for. Right? So we didn't need the whole thing. But there it is, a 37. Okay? Now I'm going to fill in the rest of this just because I can. But I'm going to do it more verbally. I'm not going to do as much calculation, I don't think. If we go backwards, how did we get to 25? Well, we must have added 12 to whatever's over here. So 13 plus 12 is 25. That's great. And now, well, how can we do the rest of this? Well, for example, we could say 4 plus d plus another D plus another D is 25. So 4 plus 3 Ds is 25. 4 plus what is 25? 4 plus 21 is 25. 21 divided by 3 must be D then. So we go up by 7s. So you get 11, then you get 18, and then you get 25. And we can do the same trick. You know, how do you go from 7 to 37? You add 30, so you must be going up by 30 over 3, 10 each time. 17, and 27. And then you can work out the patterns. You know, this column's going up by 6s each time. This one's going up by 9s each time. Okay? And so you go backwards, it must be 5, and it must be 9. And you can see, oh, this one's going up by 4s each time. This one was going up by 6s. This one's going up by, this one's going up by 7s. This one's going up by 10s. This one's going up by 13s. And you might notice something. I mean, the question's long and done, but if you've stuck around, you might notice something here. Something that might help you for a more advanced question when it comes to arithmetic sequences. Okay, we're going up by 4s. First one. Then 7s the next row. Go up by 7s the next row. Then 10s the next row. Now, 4, 7, 10, where have I seen these? And 13? Why, these are forming an arithmetic sequence. And if we go down, we're going down, go up by 3s in the first column. Then what was it? It was 6s. Then 9s. And in the last column, we go up by 12s between each square. 3, 6, 9, 12. That's an arithmetic sequence too. And that's kind of interesting. A useful observation. Now, I'm not going to do anything more with this, but it is kind of interesting to look at these sort of grid questions where you say, all right, everything's got to be an arithmetic sequence. You maybe start with some number here, and then you go up by, say, 4s over here or something. You maybe go up by n's, a plus n, a plus 2n, a plus 3n. And if you go down, you go up by m's, a plus m, then, well, how are you going to make arithmetic sequences here and here and here and here? You're going to have to make a couple choices for the numbers that you make, but only a few choices a number, this a, this n, this m, and then whatever number is here. As soon as you know these 4, you can work out the pattern here and 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 here. It can all be very, very interesting stuff. Okay, but I'm not going to play around with your general grids filled with arithmetic sequences. But if you're interested in that sort of thing, by all means, play around with it. But I just think it's kind of interesting that, oh, we get the numbers that we're adding up each time are themselves arithmetic sequences. And if you want to play around with this sort of stuff, try and see why. But if you're just here for the answer, well, there it is. The answer is A, 37. It didn't take us too long to figure it out. And we certainly didn't need to know the answer for the whole grid to get it. Okay? So thank you guys so much for watching. I will see you for question number 22 in the following video. Take care.